Hi guys, today we will talk about Cartesian form and polar form, and also we'll have a look at how to solve equations involving complex solutions. So for the first example, we raise a complex number to power n and we want the result to be real. Now we cannot work with Cartesian form because we don't know how to expand that. However, if you turn this complex number into the polar form. So let's talk about the polar form here. So you need to work out the magnitude of that, which is easy enough. So it turned out to be 2 root 3. To work out the angle, this is what I normally do. So I just basically work with positive values. In this case, I take tan inverse of root 3 on 3. That gives me pi over 6. But this complex number is in coherent 4. So the angle must be negative pi and 6. You got to be mindful about the currents. So now you got z in the polar form. You can raise z to power n, and this is our result. Cis consists of both sine and cosine. So we know that cosine is the real part and sine is the imaginary part. If we want the result to be real, then we need to let sine to be equal to 0. So for sine of some angle to be equal to 0, that angle is equal to 0, pi, 2 pi, 3 pi. So basically a multiple of pi. So from there you can solve for n, where k is an integer. So for example, if you let n to be equal to negative 6, and you substitute into here, and then use cat to expand out, the result will be real. For the next part, so this one is just another way of saying you want the result to be imaginary. So this time you want to set the real part to be 0. For cosine of some angle to be 0, so the angle is pi on 2, 3 pi on 2, and so on. So basically you want to add a multiple pi to pi on 2, and then you solve for n. So next I want to talk a little bit about polynomials. In particular, I want to show you an easy way to expand the factors out. So in this case, all coefficients are real. So you can use conjugate root theorem. You are given one factor here. Okay. So for that factor, the solution would be 1 plus I. Because z minus 1 minus I is 0. So z must be 1 minus I. So I let that first solution to be alpha. Since we can use conjugate root theorem, so let alpha bar to be the conjugate solution. So in this case, you got 1 minus I. So when you multiply these two factors together, so instead of using z minus 1 minus I times z minus 1 plus I just use alpha and alpha bar instead because we make my expansion easier. You can memorize this or you can just quickly expand now and then collect like term. That doesn't take long. So in the end, so I want to real z. So you know that z is equal, the real of z is equal to 1. So that's why that becomes 2 here. So next, you want to multiply this quadratic factor by the last factor. Because this one is cubic, so the last solution must be real. So you do the expansion here, and you collect like term, and now you can compare the terms. So you start with this, so negative 4 is equal to negative 2c. So from there you can work out your c value. So next we know that a plus b is equal to negative c plus 2, and we work out c. So a plus b is negative 4. Similarly, b squared minus a is equal to 2 times c plus 1. So b squared minus a is 6. So now you need to solve these two simultaneous equations. So in this case, so what you can do is, for example, you can make a the subject here. So I would be equal to b plus 4. And then you look at the second solution. So I is b plus 4. So now you substitute that into the second equation here. And then you solve for b. So in this case, b turned out to be 1 and negative 2. So for each b value, you have an a value as well because of that equation here. So basically, you got two set of solutions here. Okay. In this example, I want to talk about a special form. So you are solving polynomials in which there's only one z term. So like z power 3 is equal to 8i. So this is the method. So you want to convert ai into the polar form and then work out the first solution. So basically you take the cube root of 8 to get 2. And then for the angle, you take pi over 2 divided by 3. You get pi over 6 in this case. Because you want Cartesian form, so you can just convert the polar form into Cartesian form easily here. Keep in mind that this one is in current 1. So next, so once you have got one solution, you can work out the other one. Because you got power 3 here, the angle difference between the solution should be 2 pi divided by 3. For the first solution, your angle is pi and 6. So the next one, all you need to do is add pi and 6 to pi over 3. All solutions have the same modulus. And then you end up with this. So now this one is in the second current. Keep that in mind. So your real is negative and your imaginary positive. So last solution, you keep adding. So you add the angle 2 pi and 3 to this angle previously you have found. And this one is just on the imaginary axis. Okay. So next part, so you need to use the result from part A to solve this. So comparing z to z minus 2i, you have translate by 2 units in the positive direction of the imaginary axis. So that's why this solution here. So you add 2i to it to get root 3 plus 3i. And the second solution, you add 2i to get negative root 3 plus 3i. And the last solution, you add 2i to that to get 0.